Hello again everyone, welcome back to ptet.chemistry channel. In this tutorial video, I'll continue this section B kind of topical MCQs on topic 1, which is basically all about atoms, molecules, those stoichiometric calculations involving moles and stuff. Alright, so with these last 10 questions genre of section B in the Cambridge International A-Level, we talk about comparing three statements or three options, where we are still given the traditional A, B, C, D option, where if 1, 2, and 3 are relevant to whatever they ask you, there will be option A, and then option B is for 1 and 2, option C is 2 and 3, and option D means only if statement 1 is relevant to whatever they're asking. So in this first question, we are told that 1 mole of sulfuric acid, so sulfuric acid is H2SO4, is used to make an aqueous solution. So in that solution, you have H plus ions, you have SO4 2 minus ions, and you have HSO4 minus ions. You can imagine H2SO4 dissociates to give you H plus and HSO4 minus, but then the HSO4 minus can further dissociate to give you a second H plus and SO4 2 minus. In each of these are acid-base dissociation reaction. These are not redox reaction. All the sulfur is a +6 oxidation state. You will have covered these maybe not in GCSE or O-level or IGCSE, but you will have covered these if you had gone to redox changes in topic 6, and eventually you'll be able to work out the oxidation state of sulfur in here, and in here. They are all sulfur +6 because these are not redox reaction. So this is sulfuric acid. This is called hydrogen sulfate anion. This is called a sulfate anion. So these are examples of polyatomic ions which you would have covered, I'm pretty sure, in GCSE, IGCSE or O-level chemistry. So which statements are correct? If I check for statement 2, based on the logic of this kind of question, it says the solution contains an exactly equal number of H plus and HSO4 minus ions. If you just consider the first equation, then yes, 1 mole of these is formed alongside 1 mole of these. But do not forget that the HSO4 minus can further dissociate to give you H plus and SO4 2 minus. So considering that these can be further dissociated to give you H plus and SO4 2 minus, and they say that the solution contains SO4 2 minus, where do you think the SO4 2 minus come from? It comes from these having dissociated further. Therefore, you will have more H plus, but you will have lesser HSO4 minus as you produce the sulfate. Therefore, you do not contain exactly equal number of H plus and HSO4 minus, because of the information told that you also get sulfate, which of course you know in sulfuric acid you definitely contain sulfate anion as well. Since 2 is incorrect, therefore the answer must be D, where it's only statement 1 that is correct. And that is entirely true, because when we have 1 mole of sulfuric acid, how many sulfur atoms is present? There's only 1 sulfur atom in 1 H2SO4 molecule. So when you have 1 mole of it present, you have 1 mole of sulfur atom present. They could similarly ask you, how about hydrogen? In 1 mole of this, because in 1 mole of sulfuric acid, you will have 2 mole of hydrogen atoms. You will have 4 moles of hydrogen atoms. But that is to do with mole, and 1 mole of anything contains the Avogadro's number of particles. Since we are considering sulfur atoms, since there's only 1 mole of these giving you 1 mole of sulfur atom, it will give you the Avogadro's number of the atoms. There's just L, which is the symbol given for Avogadro's constant, as shown or as stated in your data booklet as well. Of course, they can ask you the number of hydrogen atoms in 1 mole of H2SO4. In 1 mole of H2SO4, that will be 2L. Similarly, for oxygen, it will be 4 times Avogadro constant, it will be 4L, because in 1 molecule of it, you have 4 of it. In 1 mole of this, you have 4 mole of oxygen atoms, and so on and so forth. Okay, 1 mole of SO4 2- ions contain 2 mole of electrons. So we know that is already incorrect based on 2 being incorrect. So number 3 must be wrong. If you think about it, SO4 2-, the number of proton, sulfur is element number 16, so it's got 16 proton. You have 4 oxygen, each oxygen is element 8, so it's got 8 protons. So there's the number of protons. So 16 plus 32 is just 48 number of protons. The number of electrons in the molecule, in the ion, it will be having extra electrons than proton. It will have 2 extra electrons than proton. It will have 48 plus 2, which is 50 electrons. Because it has got 2 extra electrons than proton, overall it's got a -2 charge. This will become important in your atomic structure topic. Alright, so 1 mole of SO4 2- does not contain 2 mole of electrons. It contain 50 mole of electrons. Alright, it has gained 2 extra electrons, but it doesn't contain 2 mole of electrons. Be very careful, yeah, of your terminology. Next question. So for complete combustion, 1 mole of an organic compound X requires 2.5 mole of oxygen. Take note of 1 mole of it. Okay, so if we start with number 2, this is C2H2 plus O2 will give you CO2 plus H2O. You will have learned complete combustion as part of topic 1 as well, because you do gas combustion analysis here. So 2 carbon here, because I have only 1 mole of it as stated in the question. So I'll give you 2 mole of CO2 because they'll give me 2 carbon. This is the only one that has the hydrogen. So 1 times 2 is 2 hydrogen. This is already 2 hydrogen, so I must have 1 water. So I don't put any number in front, meaning it's 1. So altogether the oxygen will be 2 times 2 is 4. 1 times 1 is 1. So 4 plus 1 oxygen is 5. So I have 5 oxygen atoms on the right. I need 5 oxygen atoms here, but I cannot change the diatomic molecular structure of O2. So what I do is 5 over 2. You might not like fractions having come from IGCSE or GCSE or O-level, where your school teacher will have taught you like there's no such thing as fraction. Well, I tell you, I really don't like whole number, because the smaller the number, the easier it is to balance. Okay, if you multiply the whole thing by 2, you would not have gotten the correct answer, because this question specifically said for 1 mole of X. For 1 mole of X, you got to have this fraction. Well, that's why there's 2.5 there. Why do you think fractions don't exist? These are balanced equations. You can't change the composition of the formula, but you can change the number in front of the formula, because that's just how you balance the whole equation. Alright, that's why we can have 2.5 mole, which is 5 over 2. Okay, so 2 is correct then. If I go a bit faster now, to balance the combustion of alcohol, so you can burn ethanol, which is, like some countries uses ethanol as a biofuel, and you can get ethanol from fermentation of sugar, which is something you will have done in before you start the A-level chemistry. Okay, there is in GCSE or IGCSE or O-level chemistry. You will get CO2 and H2O when you do complete combustion of alcohol. You got 2 carbon here, so you produce 2 CO2. You don't have 5 hydrogen, you have 5 plus 1, which is 6 hydrogen. So you need 3 times 2, so you have 3 water. You got 4 oxygen, 2 times 2, and you got 3 times 1, you got 7 oxygen altogether. 7 oxygen is not 7 over 2, because you got 1 oxygen there that a lot of students always forget. 7 minus 1 is 6. So 6 oxygen atoms are required. Therefore, you need 3 oxygen molecule. Because 3 times 2 give you 6. You don't just put 6 oxygen atom, because oxygen exists as a diatomic molecule at room temperature and pressure. That is 1 mole of the compound X needs 3 mole of oxygen. So 1 is wrong. 2 is correct, 1 is wrong. You are left with option C, which is 2 and 3 must be correct, without even checking for 3. Okay, but I'm going to try and balance the equation anyway, because it's good for practice that you know how to balance equation, especially in a theory paper. You would have to balance equation. Alright, So CO2 in H2 as well, 2 carbon altogether, so 2 CO2, 4 hydrogen, 3 plus 1, so I need 4 hydrogen, I need a 2 there. In terms of the oxygen, I will have 2 times 2 is 4, 2 plus 1 is 2 times 1 is 2, 2 plus 4 is 6, minus 1 oxygen will give me 5. I need 5 oxygen atom, but I have diatomic oxygen, so again just divide by 2. It will give me my 2.5 mole of oxygen for 1 mole of CH3CHO. So we know that 3 was definitely correct because the logic of 2 being correct and 1 was incorrect. In this next question is also a combustion, but this is combustion of a hydrocarbon, compound containing carbon and hydrogen atoms only. So if I just draw CXHY, but of course we are given these hydrocarbons here. If we think about their molecular formula, which is just the total number of atoms in one molecule, so there's C3H6, there's C2H4, that is C4H8. Okay, they tell you specifically it gives you this much carbon dioxide and this much water. All right, so if I just write the balance equation, if I check for number 2, if actually before I even start, you should be able to work out the balance equation using algebra, where you will get CO2 and H2O. If I use algebra, hydrocarbon is CXHY because compound containing carbon and hydrogen only. If I have 1 mole of these, so 1 mole of these will have X number of carbon. So there's no other carbon containing product apart from CO2. So that must be X. There's no other hydrogen containing product X apart from water. This is Y. If I have Y number of hydrogen atoms, I need Y number of hydrogen atoms. If I put Y there, I have 2Y hydrogen atoms, so that's why it's Y over 2. Y over 2 times 2 will give me Y number of hydrogen atoms. If you work out the number of oxygen atoms, you will get 2X from the CO2. You will get Y over 2 from the H2O. But then we had the same problem as before. This is number of oxygen atoms. This is oxygen molecule. So this thing needs to be divided by 2. So 2X plus Y over 2 needs to be divided by 2, because divided by 2 times by 2 will give you exactly this number of oxygen atoms to balance on the left. That is your simple algebra. So 2x over 2 plus y over 2 divided by 2 is going to give you x plus y over 4. So this is where your general balance equation for complete combustion of hydrocarbon actually come from. Not that it matters, okay, because this question is really about, you can balance the equation from scratch for each one of them, and then you can check that when you completely combust them, what is the ratio of the CO2 and the H2O, okay. So as you could see, the X and the Y can give you the ratio of the mole of CO2 is to the mole of H2O. Given that this is the mass of CO2, so the mole of CO2 is 0.132. So mass over the MR. The MR of CO2 from your periodic table is 12.0 plus 16.0 times 2 is 44.0. And then your MR of H2O is going to be 2 times 1.0 plus 16.0 times 1 is 18.0. So mole of CO2 is mass over the MR, 0.132 divided by 44. I get 0.003 mole. And then the mole of the H2O water product, I get 0.054 gram divided by 18.0. And I get the same value, 0.003 mole. Alright, so if I set as 1, there's 2. I was just writing this equation, but I wasn't sure if I needed it, but I think I might need it. Alright, so ideally speaking, we don't really balance it from scratch because you will have practice balancing it and you know how to get it. If you ever forget it, balance it from scratch. Alright, if ever you remember it, then you can just use it straight away. All right. So what do we get? We get the mole of CO2 is to the mole of H2O. As you could see, in this balance equation, CXHY, the mole of CO2 is X, the mole of H2O is Y over 2. So that will give you 2x over y, all right? And that is equal to, what did we just calculate? We calculate the mole of CO2 is 0.003, and the mole of H2O was 0.003. So it was 0.003 over 0.003. And of course, you could simplify the right hand side. So these are actual, these are from the algebraic expression, okay, the balance equation. So that thing can be expressed as 1 over 1. So if you have equal, so that means the top bit equal to that, the bottom bit equal to that. So 2x over y is equal to 1 over 1. So what can we say? Well, we can say that y is equal to 2x, all right? And if y equal to 2x, our CXHY is equal to CXH2x. So it means that the formula of the hydrocarbon is CXH2x will give us the mole of the CO2 is to the mole of water is exactly 1:1. So CXH2x is the general formula for a straight chain alkene like CnH2n, CXH2x. We have CXH2x, all right? So your x equal to 2, x equal to 3, x equal to 4. All of them satisfying CXH2x. I've used x because, I started out with x. Instead of thinking about CnH2n, we have just done the calculation to show the mole ratio is 1:1, giving us this mathematical relationship where I put the y equal to 2x, and I could see the molecular formula is true when I have this formula of the molecular formula of the hydrocarbon being this. It will give us the ratio of CO2 and the ratio of H2O being 1:1 for the mole, where we just did mass over mR and mass over mR. Okay, so all three of them satisfied, so the answer must be A. Okay, of course in the real deal we'll be working a lot faster. I'm just showing you how to get there. Question 9, this is another combustion analysis. So we have an organic compound. They give us the volume, which is 10 cm3. This is in the gaseous state, and that is important because the mole of gas is equal to the volume of the gas over the molar volume of the gas. All gases will have the same molar volume and the same temperature and pressure. So at room temperature and pressure, that value is 24 dm3 per mole or 24,000 cm3 per mole. But at any other conditions, if temperature or pressure changes, then the molar volume can change as well. Okay, but this thing is essentially a constant at a particular temperature and pressure. So the mole of gas is proportional, directly proportional to the volume of the gas. So when we say the mole ratio of gas is going to be equal to the volume ratio of gas. That is a true relationship as a result of this. Okay, so this is saying that the mole of gas is directly proportional to the volume of the gas. It's not a ratio, but now I'm talking about the mole ratio of gas where I'm comparing gaseous J, and then I have excess of oxygen, which is a gas, steam, which is a gas, carbon dioxide, which is a gas, nitrogen, which is a gas. So very important there. Yeah? They are all measured at the same temperature and pressure. So all of them will have the same molar gas constant, which they don't tell us is room temperature and pressure. So we cannot assume that it's 24 dm3 per mole or 24,000 cm3 per mole because they did not specify its room temperature and pressure. But what we know is that it's going to be constant for all the gas because they all measure at the same temperature and pressure, right? So what could be the identity of J? what could be the identity of J? All right. So let's start by comparing. Volume ratio, because we are given volume, all right, and they will tell us the mole ratio based on the number of atoms here. Okay, if I check number 2 first, C2H3N, that will give me, so I'm comparing that to CO2. No, let's compare H2O first. Steam, I don't actually need to know steam because they don't give me the volume of steam, you see, they just say steam. They give me the volume of carbon dioxide, they give me the volume of nitrogen. So they don't give me the volume of steam, so I don't really need to compare. I don't have anything to compare steam to, you see, okay? But I have the volume of carbon dioxide and nitrogen. For 1 mole of the substance, well, for 10 cm3 of this thing, it's completely used up because you have excess of oxygen. So oxygen is in excess, this therefore is limiting, it's completely combusted, okay? And you get how much CO2 did you get? You get 20 cm3 of CO2 and you get 5 cm3 of nitrogen. So because each of these is cm3 and we are doing ratio, we can divide everything by cm3 and they will cancel out because it's a ratio. Volume ratio of gas is going to tell you the mole ratio of gas as well, all right? So I can simplify by the smallest number, divide by 5 throughout, and I'll get 1. Actually, I don't want divide by 5, I want divide by 10 because I want to show for 1 mole of these. It's very important that you get 1 mole of these, and I'll tell you why in a little bit. I don't want divide by 5, I want divide by 10 because I want this number to become 1. 10 divided by 10 is 1, 20 divided by 10 is 2, 5 divided by 10 is a half, or you can think about it as 0.5 decimal. So 1 mole of these will give me 2 mole of CO2. Is that correct? Well, have a look at the formula. The formula has 2 carbon. You only get steam, which has no carbon. You only get nitrogen, which has no carbon. So all the carbon and carbon dioxide must have come from the thing that you combusted, which is containing carbon. All right. So it's got 2 carbon. One of these has 2 carbon, so it will give you 2 mole of CO2 in the balance equation. The nitrogen here will give you the nitrogen product because there's no nitrogen in steam. In case you don't know, steam is H2O gas. There's no nitrogen there. Carbon dioxide has no nitrogen there. So this nitrogen, okay, occurring as N2 molecule at room temperature and pressure, must come from this nitrogen. Remember, 1 mole of this has 2 carbon atoms, so 2 CO2. It's got 1 nitrogen atom, so that's why this is molecule. 1 over 2 times 2 will give you 1 nitrogen, 1 mole of nitrogen atom as well. So this satisfies the relationship for the formula given. So number 2 is actually correct. It will give you whatever volume that's stated, all right? So let's check for number 1. Number 1 will be C2H6N2. Okay, if we look at that, remember the volume ratio is the same because it's only given as one set of reading, right? They want us to find out which one could be the identity of J. So what happened then is I have the same volume ratio as what I calculated before. There's no need for me to calculate it again. But instead, I'm just going to compare the formula. In 1 mole of these, I have 2 carbon. So 2 carbon, because I already make it into 1. I have 2 carbon, 2 CO2. I have 2 nitrogen atoms. Here, we have half time 2, which is 1 nitrogen atom. So that is not true because you want 2 nitrogen atom. It should have given you 1 here, which is 1 times 2 will give you 2 nitrogen atom, but you get a half. So 1 does not satisfy the relationship there, and therefore 1 is incorrect. 2 is correct, 1 is incorrect. You're only left with option C, which of course you can check. Option C would mean 3 is also correct, and you have 2 carbon, so they will give you 2 CO2. You have 1 nitrogen, just like before, so you get 1 over 2 times 2 will give you 1 nitrogen atom, and in fact they will satisfy this ratio as for option 2, so that's why 3 is also correct. This is the last question of this 5 questions series on the section B topical MCQs. So when oxygen reacts with H2S, you get SO2 and H2O. So now you have a mixture. This mixture contains equal number, okay, equal number. No other molecules. You have equal numbers. So if you have 5 of these, you will have 5 of these. If you have 10 of these, you have 10 of these, okay? So which statements about Y are correct? If I check number 2, so this is called oxygen molecule, okay? It's an element because it only contains one type of atoms. Well, one type of atoms. It contains isotopes which have different mass number, but it's the same element because they have the same proton number, okay? This is a compound. It's got 2 different elements chemically bonded together. But then if you look at the mass number, so the mass is going to be 16 plus 18, which is 34. So that is our molar mass, 34 gram for 1 mole of these. For H2S here, you need to be careful. You have to use the mass number given. So it's 1 because you have hydrogen 1, you have sulfur 32, and you have another there, which is 34. So both of these molecules have the same relative molecular mass. If you remove some oxygen molecules, what is your average MR? Well, both molecules, this is also a molecule, but this is a molecular element. This is a molecular compound, okay? So both of them have the same mass. If you remove some of these, you will still have everything that have molecular mass of 34. So obviously your average MR, where everything is 34, is still going to be 34, okay? So it makes sense that the average MR is still 34 because all of them have the same mass of 34. If you remove some, if you add some more, it's still going to be 34 because they have the same molecular mass. And of course the average MR is just 34 because everything is 34. Well, I mean everything, whether this or this, they both have the same molecular mass. When you ignite, that means you put fire to it, some of the H2S remains unreacted. Some of the H2S remain unreacted. Well, let's see. This is probably based on this equation. You probably have to write a balanced equation. Oxygen plus H2S will give you SO2 plus H2O. So let's try and balance that. 1 sulfur will give you 1 sulfur. 2 hydrogen give you 2 hydrogen. But you got 2 oxygen plus 1 oxygen. There's 3 oxygen atoms. But you have 1 times 2, you have 2 oxygen atoms. To get to 3 oxygen atoms, 3 over 2, because 3 over 2 times 2 equal to 3 oxygen atoms. So this equation is balanced now. So when you put this mixture Y, what is mixture Y? Mixture Y contains equal number of both molecules. So that means if you have 1 mole of oxygen and you have 1 mole of H2S, so it says some of the H2S remain unreacted. Well, if you have equal number of each of these, then let's say you have 1 of these, then you have 1 of these because they have equal number according to the question. So 1 mole of these require 3 over 2, which is 1.5 mole of oxygen. So 1 of these needs 1.5 of oxygen, but only have 1 because you have equal number in the mixture, right? So you need 1.5 of this because 1 of these need 1.5 of oxygen molecule. So you only have 1 of these. So we say, therefore, the oxygen is limiting. Okay, that means you don't have enough of it. That means this is the one that is the limiting reactant. It is completely used up. It is completely used up. All right. If this is completely used up, then guess what? The H2S is in excess. All right. So therefore, H2S is in excess. You will have some of it that is unreacted at the end of reaction if you ignite it. Okay. So guess what? Some H2S remains unreacted because H2S is in excess. So all 3 are correct. So that's option A. So that's the end of these section B topical MCQs, and make sure you check out the other topical playlist as well. And with the rest of my videos, if you spot any mistakes, do let me know. That's why when you go through any of my videos, do read through the video descriptions, and I credit the viewers and the students who actually spotted the mistakes and let me know, because I'm not perfect, so I do make mistakes even when I think out loud. So let me know, and I'll highlight it. I won't cover my mistake, but yeah, ideally in a real exam you will leave time to check through your answer, no matter how confident you are. Okay, thank you for watching, and thank you for sharing the channel with friends, your various class group chat, and your juniors and seniors from school, and various other social network that you socialize in. Okay, see you in the next video.